I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking today with Dr. Eugene Podkletnov, the famous Russian chemist, world-renowned for his research into superconductive antigravity and, more recently, collaborative efforts with Giovanni Modenese and Dr. Ning Li into gravity waves. Eugene, can you hear me okay?
Yes, I hear you perfectly, thank you.
Great. Well, thanks again for taking the time to speak with us a little bit more about your research. Your research was pioneering in the field of superconductive antigravity. A lot of the papers that I read online and a lot of the references date directly back to your research from the early 1990s, and more recently, some of your newer experiments with Giovanni Modenese. Is there anything you can tell us about what you've been up to lately?
Well, first of all, frankly speaking, I am not an expert on gravity. Never was and never will be. I am a chemist by profession, but I worked all my life in the field of physics. So I have PhD degree in chemistry and second PhD degree in physics. And I began to work with gravity. It happened just by chance, so I never planned it. But now I have about 15 years of very effective work in this field, and I begin to understand something. So it is a very difficult subject, first of all because it is a pioneering research, as this field of physics is practically unexplored, and the attitude of official science to gravity research is, let's say, honestly, very unpleasant. And people who deal with gravity, they usually suffer a lot. So if we refer to history, well, Giordano Bruno, one of the Italian scientists, was burned by Holy Inquisition because of his works, and Galilee hardly escaped. But now we have more or less good understanding of what is going on there. So I based my research on superconducting materials because they give a very wide possibility to vary their physical properties, especially magnetic properties, so we can create magnetic fields of different configurations. And my research is based on the idea that it is possible to change or to modify local gravity field and to create objects which are heavier than usual or lighter than usual. And this all can be done when creating special conditions. If we discuss these special conditions, some people say that we deal with the polarization of space or polarization of physical vacuum that is everywhere. And there are several ways to polarize space. We can use high voltage, we can use high magnetic fields, we can use extremely high-speed rotation of various objects, and we can also use topological effects, special grids and surfaces with special topology. And there are also other possibilities, and we can also use the combination of all these parameters.
Absolutely. Well, I'm sorry. One of the things that I was hoping to ask was, you'd mentioned in one of your papers a 20-pound or approximately 20-pound beam of force, if I remember correctly.
Yes.
That's been capturing a lot of interest lately. The media was initially interested in the rotating superconductor, and eventually it ran its course, at least in the American media, and they weren't sure where to go with it. But, the second experiment didn't quite grab the media in the same way, and I think the reason was they just weren't really prepared for it, they weren't looking for it, but the results were much more profound. Instead of a 2% reduction in weight, you would actually notice a beam of force that was knocking over things in the lab, right?
Yeah, so we are in fact discussing two types of experiments that I made during the last 10 years. The first experiment was with high-speed rotating ceramic disks made of superconductors. And at extremely high rotations, I mean the speed close to 30 or 40,000 rotations per minute and even higher, we can get the reduction of weight up to 9%, and in some cases even more, but this process becomes uncontrollable, so it's difficult to deal with it. So it's one experiment, and the other experiment, which was called gravity impulse generator. This is also a special superconducting material which is put into magnetic field, and then we have a high voltage discharge of several million volts, and then we can create a wave in the space. The properties of these waves are very close to gravity waves, so we are practically sure that it is the same thing as gravity, and these impulses can be forwarded to any direction in space, and they are able to push different objects on their way of propagation. So if we speak about the detailed mechanism of these events, we are still working on it. But at present we already have a possibility of semi-industrial and later commercial application of the first results, and this is the most important.
Oh, absolutely. Well, am I correct in the 20 pounds figure, or have you been able to generate more force since then?
At extreme parameters, we can create even bigger forces. If we go to 5 million volts, this information was not published yet. So during last year and a half, I was with my team. I was trying to investigate the interaction of this gravity impulse with different objects, the interaction of this impulse with light, and we were also trying to measure the speed of the propagation of these gravity waves. And the results were extremely interesting. The word interesting is forbidden in our laboratory. I don't know how to discuss it, but this is practically unbelievable because to some extent it contradicts many aspects of modern physics, but we have experimental proof and we are going to develop all these experiments.
Oh, so these are much...
So,
I'm sorry, much
it is
larger.
possible to use high voltage discharges up to 5 million volts and specially prepared superconductors. These impulses are very short in time. We speak about millions, 1 million of a second, something like this, and even lower. And they can be very powerful and can be used for rocket propulsion in space. At the same time, they can be used for the correction of the orbits of several satellites, and this can be done from Earth with minimum expenses. So this is quite promising technology.
Oh, okay. So this is probably, well, I don't know if it's too far to venture, but do you think for at least a nanosecond's worth of time, maybe 100 pounds of force, or perhaps even greater than?
Even greater.
Oh, wow. That's this is amazing. It's amazing to see. I mean, you've been getting results for years, and I've been following the work of Robert Baker Jr. and Dr. Ningley and several others online. And one of the things that they've based a lot of their research on is your experimental results. But in a way, it seems kind of humorous that they keep working on the mathematical, theoretical side of things, and yet day in and day out, you're coming up with these new, more impressive demonstrations. I think history is really going to record you as kind of the discoverer or the founder of modern anti-gravity. And I think the reason is experiments like these.
In fact, if we use the term anti-gravity, it is not quite correct. So we can speak about experimental gravity, and our research is called experimental gravity research. If we speak about polarity, I don't think that gravity has polarity. It simply has the direction of propagation. But to speak about polarity, this can be argued a lot, and we'll get lost in it. But anyway, I'm very much obliged to Dr. Ning Lee for her understanding and for different discussions with her, as well as with Dr. Modanese, who is an extremely talented guy in this field in Europe. And I keep contact with Dr. Harold Putov, and I know in details his theory of zero-point fluctuations of vacuum. So it seems that my experiments combined all these theories and can be based on all these theories.
Oh,
so this is important.
Definitely. Now, in terms of experimental setup, because I've actually been attempting to, I'm actually getting ready to buy parts, but it looks like, from reading through your experimental setup, essentially you're discharging a high voltage onto a superconductor. Is that, and the superconductor is in a magnetic field? It looks in some ways deceptively simplistic, but I understand that there's a definite challenge involved with it. Have you found any real tricks to testing with this?
Yes, this technology is, there is nothing special, but I work with a team of experienced people who are experts in high voltage discharges, who are experts in ceramic materials and superconductors, and who are experts in magnetic fields. And only combining the knowledge of different fields and people from different countries, we can reach something positive. So this international cooperation becomes inevitable and becomes a key to the success.
Definitely. The international collaboration has picked up so greatly over the last 2 or 3 years even also, at least in the community that I've been working with. The lifter technology has given us incredible results, but there have always been efficiency issues that have prevented it from going much farther than it has. Do you have any insights on lifter technology or perhaps Diakino's ELF technology?
Sorry, could you repeat just...
Oh, I'm sorry. I was just wondering if you might have any insights on the lifter technology or Fran Diakino's ELF technology from Brazil.
We exchanged a lot of letters with Professor D'Aquina from Brazil, and I respect his approach. It's also a bit unusual. He uses extra low frequencies, which is also possible with ceramic superconductors, and I'm trying to work on it. Also, there is a very interesting effect called Byfield-Brown effect, and the famous lifters, first developed by the engineers from NASA and then repeated all over the world. So these are also the pieces of the puzzle, which is called anti-gravity. And every approach is very useful, and combining all this information together, we can slowly but surely come to the understanding of the mechanism of gravity. Because if we speak about mechanism, I studied in details the works of Sir Isaac Newton in the library of the British Museum, and practically all the translated works of Dr. Einstein. And they give the interpretation of gravity forces, but they never discuss the mechanism. And nobody in the world still knows how it works. And without that detailed understanding, we can't reach good progress. So unfortunately, in modern physics, this direction, experimental gravity research and theoretical gravity research, is not a very popular one, but it is becoming popular, and I'm sure that in this century, in the period of 10 to 15 years, we'll have amazing discoveries in this field.
Well, absolutely. I think a lot of those will be based directly on your research. You know, you've gotten results that no one has been able to get so far, and I think that puts you, decades ahead of, certainly decades ahead of mainstream science, who still seem to kind of be working on string theory, but also you're farther ahead from most of the experimenters I've seen. Also, it's really quite remarkable. Well, in terms of commercial applications, then, do you think it's possible we'll see something like flying cars in the near future?
I think it's possible to speak about gravity platforms, which will work like enormous hijacks. But later it will be possible to develop how can we call it? Not a flying saucer exactly, but a new type of vehicle that uses new physical phenomena and can be named as anti-gravity spaceship or something like this. And of course, some people, especially professors of physics, can be very skeptical about it. But if we discuss quantum theory and the theory of relativity of Einstein, everybody will agree that there are very big contradictions between these two theories, and they practically cannot be solved. But that does not keep us from applying both theories for different practical applications in science and technology, and still there is big contradictions between this theory, and all physical world usually close the eyes on this, and they think that it can be those both theories can coexist, and I agree that it is of course possible. And all the results, all practical results that we got with gravity work, if we have a detailed analysis, they don't contradict any normal law. Because, well, sometimes people write to me that I go against Einstein. But Einstein's theory is a relativity theory, and usual motion is relative. But if we speak about the rotation around the axis, the own axis of the object, then we speak about absolute motion. So the theory of relativity is not applicable to absolute motion. That's why that's why I don't go against Einstein. And well, there are many things in modern physics that cannot be explained, not because they are incorrect, but simply our understanding is not yet overwhelming. But I hope that with some efforts we can overcome all the obstacles and approach a very good stage of practical application. I had some experience working and consulting people from NASA, but frankly speaking, they have extremely big funding for normal projects like International Space Station and shuttles, and extremely low money for new propulsion systems. And the only real gentleman and scientist and a man whom I respect greatly was John Glenn, who always supported the idea of gravity vehicles and was always trying to organize something new in NASA and in their research plans. But unfortunately, not everybody is listening to him. And that's one of the mistakes that I think people from NASA headquarters are doing.
Definitely.
It's my personal opinion, of course.
Oh, well, it makes sense. NASA is very invested in current technologies, and in some ways, it's not really in their interest to pursue new technologies, and that's been kind of a frustration. They have these organizational hurdles that they have to overcome before they can even really think about new technologies. And so, in some ways, it's easier for independent experimenters to do it, although things like funding become major issues. And I've definitely been in the same boat with my research. But John Glenn hasn't been the only person though. I just saw a clip. In fact, I can email it to you from Arthur C. Clarke from the 1960s, predicting that these devices would become practical. And Clarke's speculation was that despite the lack of support in 1960s science for these things, that the human race is far too creative to just let the opportunity pass by. That and then Nick Cook was just talking about the Kondratiev interval, and I believe that relates to transportation, a 55 or 60-year cycle between major breakthroughs in transportation. And according to Cook, we have about 7 years left on this current interval that we're in. So, maybe, within the decade, we'll be leaving the age of jet transportation and moving into something else.
Well, it's my dream to work for the International Institute for Gravity Research and to get the practical application of all the experience that we had in Russia and in Finland, in Italy, in Canada, in Britain, in the United States. Because there is a big group of scientists, I should say, very talented, very persistent, and if their forces are organized in a good way under the guidance of the International Institute for Gravity Research, our planet will be getting very good results and will progress immensely in this field.
Oh, absolutely. Well, I'd like to continue this interview at a later time. I sincerely appreciate your time for today. And this is definitely something where I will put together a much better list of questions. And then we can go over it topic by topic, if that's okay with you.
Yes, it's quite okay with me, thank you.
Okay. Well, again, I sincerely appreciate your time, and I will put this up on the website so that people can immediately begin to listen to it. It's wonderful to hear that you're getting the kind of results that you are, and there's definitely an entire world of questions that we could go over in the future. But thanks again for your time, and have a great day.
Okay, thank you very much.
Thanks.
Same to you.